So my name is Ombu A, and I have been in the STEM program for 3 years. Now, some of you may know that the STEM stands for 4 different disciplines: science, technology, engineering, and mathematics. But how do those fit together? Let's take a look at 2 examples of projects from this year. I'll briefly explain how each discipline fits into our aquaponics project and our passive house project. Now, the first project I want to talk about is aquaponics. Aquaponics is a system for combining aquatic creatures and hydroponics, which is a method of growing plants without soil, in a sustainable way. Our current agricultural practices need improvement, and aquaponics is one way to do that. Now let's talk about the science of aquaponics. A key factor to understanding aquaponics is the nitrogen cycle. Fish need nitrogen as it is their protein, and like us, they need it to survive. They intake the nitrogen by eating their food and then excrete it via their waste in the form of ammonia. This ammonia makes the water acidic, and if it builds up, it can be deadly to the fish. Now you can see the problem here. The solution to this is plants, as they are able to essentially filter the water. They absorb the nitrogen, but they can't absorb it in the form of ammonia. So as part of a 3-step process, different bacteria convert the ammonia into nitrites and then into nitrates. And once it's in the form of nitrates, the plants can use it as their fertilizer, leaving the water fresh and clean and the fish safe. Now, another issue addressed in aquaponics system is pH levels. We need to know chemistry in order to solve this. Fish thrive in a certain pH level that isn't too acidic from the ammonia, like I mentioned earlier. Now, we realized that we would have to be monitoring and adjusting the pH levels constantly. Now, who would want to do that every single day? We asked ourselves, is it possible to automate this process? Here's where we went to technology for a solution. We designed and made a pH monitoring device. This involved programming and wiring the pH monitor, as well as recording the data. Now, where did math come up in this project? We did a lot of mathematical modeling in the design of our system. What size pump and heater do we need? What rate should we feed the fish? How do we right-size the number of plants to filter the water? This math was integral for our project to function. Now that's how our aquaponics system fits together and how each subject is crucial to the whole project. The disciplines all have their own part in creating the system. As Aristotle said, the whole is greater than the sum of its parts. What I've learned in the past 3 years is that in real-world applications, these disciplines are always going to be interconnected. In fact, it's really only in theory when you can attempt to isolate them from each other. Connecting these topics is logical and effective. Okay, let's look at another example. Climate change is real, and it's a huge issue. How can we as individuals make the difference? We need to do a better job of heating and insulating our homes. The truth is, Vancouver's standard of house insulation is very low, and most people use gas to heat their homes. Can we design homes that leak less heat, as well as use solar power to offset gas? Now, where's the science in this project? Thermodynamics is the branch of science relating to heat. There are 3 different kinds of heat transfer: conduction, convection, and radiation. We used these theories to model and design our main experiment. Now, for our actual experiment, we constructed 2 model homes out of rigid insulation to demonstrate the difference between high and low values of insulation, similar to a passive house and a Vancouver special, which is what we named them. Now, how can we use technology to run our experiment? We had heaters in both the houses, but how do we build a thermostat? How do we monitor the energy use of both homes? We used an array of 8 solar panels to power the houses. How do we control the flow of energy? This gave us a chance how to wire the solar panels, how to properly construct the houses, as well as how to program temperature sensors and heaters. Now, did we need math for any of this? Throughout the project, we're always doing calculations and estimates. For example, can we predict how much heat these houses will lose? And how many solar panels are required to keep up with that loss? Statistically, How much solar radiation can we expect in Vancouver, and how many batteries will it take to store it for when we need it? We used the heat loss equation to calculate the heat loss and determined that we would need an array of 8 solar panels and 2 deep cycle batteries. Now, these are just 2 examples of many, many projects we've done throughout the years in STEM. This format allows us to learn the skills, but most importantly, apply them. I'm aware how applying skills, troubleshooting, and project management are all abilities that I got in STEM, but I now use in my everyday life, not just in school. And for me, honestly, these projects are such a fun and exciting way to combine these disciplines and learn so many new things. It's really amazing to see how at the end of every project, everything fits together so nicely and every element is crucial to the project. I'm really happy that I chose to join STEM in grade 8. I know this probably sounds like an advertisement for STEM, but honestly, this is really the perfect fit for me. I enjoy coming to school and I'm never bored and always up to something new and interesting. I'd like to quickly finish with a quote from the early French mathematician Henri Poincaré, which I think applies to this. Science is built up of facts, as a house is built of stones, but an accumulation of facts is no more a science than a heap of stones is a house. STEM combines these 4 disciplines because they work better together. I'd like to thank everyone for coming out and watching our presentations. It really means a lot to us. I hope everyone is doing well and safe. Thank you.
Thank you.